Hi, my name is Amy, and this is my Physics 2 charged tapes lab. In this lab, I investigated how electrically charged pieces of tape interact and use experimental data and computational models to estimate the charge on a tape. The goals of this lab were to observe charged tape interactions, estimate the excess charge on a tape, and compare a point charge model with a line charge model. My tape length was 20 centimeters, the mass was 0.2 grams, and the floating distance was 0.5 centimeters. Using the point charge model, I calculated a charge of approximately 2.33 times 10 to the negative 9 coulombs. This lab uses Newton's second law, Coulomb's law, and gravity. Because the tape was floating, the upward electric force balanced the downward gravitational force, so the net force was 0. I created a base tape, attached a second tape, pulled off the upper tape to create a charged U-tape, repeated the process for a second U-tape, and then brought the tapes together to observe their interactions, and here's my group doing that. The U-tapes repelled each other, showing they had the same type of charge. Neutral objects were attracted because of polarization. One tape floated above the other, indicating that the electric force balanced gravity. The U-tape was also determined to be positively charged because it was attracted to a negatively charged pen. The system was the floating tape, and the surroundings was the base tape and the earth. And then here are the experimental data again. For the gravity calculation, I used F equals mg and substituted the values of 1.96, I substituted the values for the mass, which was 0.002 and 9.8 for gravity, and then that resulted in 1.96 times 10 to the negative 3 newtons. In the point charge model, each tape is treated as a single charge located at its center. Assuming equal charges on both tapes and neglecting air resistance, I used Coulomb's law and solved for the charge. The result was 2.33 times 10 to the negative 9 coulombs. To estimate the number of electrons transferred, I divided the charge by the charge of one electron, and then this gave approximately 1.45 times 10 to the 10 electrons. The line charge model is more realistic because the charge is spread along the tape instead of concentrated at one point. The code divides each tape into multiple small charges and calculates the interactions between them. The model predicted an electric force of about 3.38 times 10 to the negative 3 newtons, which is in the same order of the magnitude of gravity and reasonably matches the experiment. The point charge model produced a charge of 2.33 times 10 to the negative 9 coulombs, while the line charge model produced about 9.59 times 10 to the negative 9 coulombs. Because the real tape has charge distributed along its length, the line charge model should be closer to reality. If electrons were positive and protons were negative, the observations would not change. Like charges would still repel, opposite charges would still attract, and only the labels would be different. Sources of error include uncertainty in measuring distance, charge leakage, and even uneven charge distributions. Overall, this lab demonstrated that electric forces can balance gravity and that the line charge model provides a more realistic representation of the tape than the point charge model. Thanks for watching.